Let's discuss using our balances in the laboratory. This is a laboratory balance. Notice that the balance goes down to 3 spots after the decimal point. General rule in our laboratories is that when you use these balances to measure the mass of your sample, you always record every number it gives you. To use the balance, before you place anything on the pan of the balance, you need to tare it or zero it out. What you will have a button to push on it. On this particular one, there are little gray pads in the lower left right corners that say 0/T. I press that. It resets the display to 0.000 grams. Then I go ahead and measure an object. Now, sometimes you can place things directly on the pan of the balance, and other times, particularly when you're putting chemicals on the balance, you want to make sure you use a weighing dish. So for my first object I'm going to measure, I'm going to go ahead and use a weighing dish to determine its mass. So before I put my sample on, I'm going to put on a little disposable weighing dish. Notice it's now giving me the mass of that dish. Well, I don't really care about the mass of the dish for this exercise. I want to know the mass of the object that I'm going to put into it. So the first object I'm going to measure is a test tube. So I can get the mass of the test tube without the weight of the dish. While the dish is on there, I re-tare it. It now is reading 0 grams again. It's ignoring the mass of the dish, and it's only going to give me the mass of the sample that I'm about to put inside of it. So I'm going to take a test tube. This is a 16 by 100 millimeter test tube. I'll place that into my dish. All right. Let the balance steady out. In this particular balance, there's a little asterisk on the left-hand side. When that asterisk appears, that means that the reading is stable. I'll go ahead and record this number. Now, this last digit may still jump around a little bit. That's where the uncertainty is in this measurement. And with air currents in the room, people moving around in the room causing vibrations, that number may go up and down a little bit. But as soon as you see the marks indicating that it's stable, record whatever the number is at that time. But you notice if I wave my hand over it, the air currents affect the measurement. That's how sensitive the balance is. All right, so there we go. There's our mass of our test tube. You record that on your report sheet. A few more objects I want to record. Next, I'm going to do next thing on the report sheet is a beaker. So I've got a 100 milliliter beaker. Notice beakers have these straight sides, slanted sides. It's going to be a different type of glassware called an Erlenmeyer flask. I just, again, before I put it on there, I want to tare or zero the balance. I put my beaker on there, and I wait for my reading to stabilize and record the mass. Next, the next item on the report sheet is a spatula. So in the student drawers, there are usually going to be some spatulas. Most of the spatulas are this type. It's actually called a scupula, where we've got a thin piece of metal that's curved. It's got one end that's pointed. And I'm just going to, again, make sure my balance is tared. Place that on the pan. And record the mass. Finally, the last object is going to be a graduated cylinder. I've got a 10 milliliter graduated cylinder. Right. Make sure it's tared. Place it on there. Record the mass. Now, you will not only want to record this in part 1 of part B of the experiment, but also record it as the mass of the graduated cylinder at the top of part 2 of the laboratory balance section of the experiment. The procedure we're going to do next, which is precision. So that's the use of our laboratory balance.